Great, so here we are again. Let's take a look at D on these examples. I want to go through and find each of these things before I get started. My amplitude is the absolute value of the number in front, so the absolute value of -1, which is 1. The period is 2 pi divided by the number in front of the x, which is a 2. And so this graph is going to be shrunk a little bit. It's going to be a little bit tighter. It only goes to pi instead of 2 pi. The vertical shift there's going to be a +3 at the end, so this is going to go up 3. And the horizontal shift, the way that we want to do that horizontal shift is we want to do a starting point, which is going to be at 2x minus pi over 2 equal to 0, because that's where my sine graph starts. My sine graph starts at 0, and so when I do that, I get 2x equals pi over 2, divide by 2, and x equals pi over 4. So this is my starting point on my graph. My starting point is here at pi over 4. And then, so that this doesn't really run together, I've got 2x minus pi over 2, set that equal to 2 pi, and that's going to find my ending point. So I'm going to add 2 pi to pi over 2 to both sides. When I do that, I get 2 pi plus pi over 2. I get a common denominator here, so this is 4 pi over 2. So I get 2x is equal to 5 pi over 2. Add those together. Divide by 2. When I divide that by 2, I get 5 pi over 4 as my ending point. Well, it should make sense that if my starting point is at pi over 4, then if I'm going one more pi past that, okay, from pi over 4, one more pi would be 4 pi over 4. I should end up at 5 pi over 4. Okay, so all of the stuff should make sense that when I plug this in here, it should be a logical choice as far as the math that goes behind it. I have a period of 1 pi, so from beginning to end it should be 1 pi. So from pi over 4 to 5 pi over 4, it should be a distance of 1 pi, and it is. And that distance between those two is 1 pi. And I can find that by 5 pi over 4 minus 1 pi over 4 is 4 pi over 4, which is just pi. And so we know that that all of this stuff needs to check out when we're looking at this. Since we're working on that portion of it, we can plug in the halfway marks here. So 5 pi over 4 plus pi over 4. Then I'm going to divide that by 2. Gives me 6 pi over 4. When I divide that by 2, I get 6 pi over 8. I can reduce that. 2 goes into both of those. I'm at 3 pi over 4. So this is at 3 pi over 4. Well, if I've got 1 pi over 4 and 3 pi over 4, in between here is 2 pi over 4. But I should reduce that to give me pi over 2. Halfway in between 3 pi over 4 and 5 pi over 4 is 4 pi over 4, but I should reduce that to give me a pi. So I have all of my values here, all of the places that that this graph is going to be represented on the x-axis. So go ahead and plug those in if you wanted to as you're working with that horizontal shift. You've got a beginning and an end. Even though it's the last thing that you're adding in the graphing process, it's still okay to throw them in there on the x-axis so that it helps a little bit in your graphing. Okay, so we want to start with the vertical shift. So this is going to go up 3. So here's my new x-axis. This is the point that everything happens at. That's the place where the graph is going to cross. And I've got an amplitude of 1, so it's going to go up 1 to 4 and down 1 to 2. And again, the closer you can make these to look like they're the same distance, the better off your graph is going to look in terms of its amplitude. I had a period of pi. I did that. I did the horizontal shift stuff already. So I've got a sine graph. The sine graph starts at at the place at the origin, but I moved that up 3, so it starts at the new x-axis that I have here. Okay, um, and the original one goes up and comes back down. Well, when I look at this, I have done that phase shift, and so my starting point actually is right here at pi over 4, and my ending point is way over here at 5 pi over 4. Okay, we know that in between, the graph goes up and comes back down and then goes back up again. Okay, but what's wrong with this graph? That's right, there was a negative in front, and so I have to account for that negative. And so that means that the graph, instead of going up first, is actually going to go down first. So this is going to go down here, and this is going to go up here. And all of these things you have to take into account when you're graphing these. And there's a lot of stuff. I know there's a lot of stuff. But you have to take into account every single piece of it. So this amplitude had a negative. When I took the absolute value of it, it still changed it to a 1 for an amplitude. However, it didn't change the fact that this graph has to be flipped upside down. Okay, so it has to be reflected. So if you want to put that in there, that if you wanted to remind yourself that this is reflected, you can go ahead and put that in there as something that helps you to remember it. But it's an important thing that gets added here. Let's take a look at this last one. The amplitude is the absolute value of -4. So again, if you wanted to put in there the fact that this is reflected, so that you didn't forget, that would be fine. The period is 2 pi divided by the number in front of the x, which is a pi. So the period is going to be 2. So there's going to be a distance of 2 in between our starting point and ending point. A vertical shift of down 2. A horizontal shift, we're going to take this start equal to 0. I'm going to add 1. Pi x is equal to 1 divided by pi. I've got x equals 1 over pi. Good. Now that seems like a goofy number, but remember this is just places that we're putting on the x-axis. It's 1 divided by 3.14159 going on. Okay, but it ultimately is a place that I'm putting on the x-axis. I'm moving this graph that far to the right. Okay, and so my ending point, I want to set this pi x minus 1 equal to 2 pi. Add 1 to both sides. Pi x is equal to 2 pi plus 1 divided by pi. And I get x is equal to, when I divide this, I can leave it like that, but I think it makes more sense with our period when we do this. Take the 2 pi and divide by pi is 2, and take the 1 and divide it by pi. That's 2 plus 1 pi. So if I started at 1 pi, and I ended at 2 plus 1 pi, that means that I went a distance of 2, which is exactly what the period said. Okay, so that those two things match up. So I start here at 1 over pi, and this is not to scale. Okay, 1 over pi is not that far away from the x-axis. If you're looking at this, if you're looking at this in terms of this graph being matching up with the last graph, but it does match in what ultimately the graph will look like. So if you put them on the same screen on your calculator, they would not look the same as these two separate graphs will look. Okay, this is more zoomed in, you would say. So I've got 2 plus 1 over pi over here. So this is my beginning point and my ending point. The other things that we need in here, we need a halfway point. Okay, so I'm going to go 2 plus 1 over pi plus 1 over pi. And then I'm going to divide that by 2. Well, that gives me 2 plus 1 over pi plus 1 over pi is 2 over pi. Well, when I divide those by 2, I end up with 2 divided by 2, which is 1, and 2 pi divided by 2, which actually is 1 over pi. Well, again, should make sense, because if I went from 0 to 2, halfway in between would be 1, but I added that 1 over pi, and so I'm going to be at 1 plus 1 over pi. And then if you want to figure out those two middle points, you could do that too, but I want beginning, end, and complete middle for that one revolution, one period. So now we can start graphing. So I've got a vertical shift of down 1, down 2. So this graph is going to go down 1, down 2. And that's going to be my new x-axis. Everything's going to happen at that point. My amplitude is 4, so it's going to go up 1, 2, 3, 4, and it's going to go down 4. Let me change this just a little bit so that I have some extra room here. If you need to, hopefully you have this stuff written down. I just need some extra room because I'm making my graph too big. So down 1, 2, 3, 4. So it goes down 4. Okay, so I had a vertical shift, an amplitude of 4. If you remember, I have all the period stuff in here. I have all the horizontal stuff in here already. What I'm looking at is a cosine graph. The cosine starts at the top, the top of its amplitude, and starts at the phase shift already. So starts at the top of the amplitude at 1 over pi. That's the starting point. It's going to go down, but now that I erased the reflected, I remember that it was reflected. So it actually starts at the bottom and goes up. So at this point, it crosses the x-axis at 1 plus 1 over pi. I'm way up here at the top of its amplitude. Then I come back down, and then I'm finally down here at the same point that I started. For that cosine. So it should look like a cosine graph flipped upside down. It has the phase shift of down 2 vertically and a horizontal shift of to the right 1 over pi and has a period of 2. And so you go through and you look at this graph. The ideas behind these things are really the same as what we did with parent functions, the original parent functions, except that we're looking in cosines and everything has pi's in it, which is kind of a fun way to be doing these graphs, but it also is kind of a little bit of a confusing way as well. Okay? But the way to get better at these is to just graph them. Keep graphing them. Graph more of them. Graph more of them. Keep graphing them.